Hello everyone and welcome to the video. My name is Sarang Shibu and I'm a robotics graduate student at the University of Maryland. I was enrolled in the autonomous robotics course this spring semester, and over the semester I've been working on a very exciting project where I built and programmed an autonomous robot. Now, this video is a journey through my experiences and the learnings, and it's broken down into four sections. That is the setup of the robot, the assignments that we did, the logic for the grand challenge, and finally the robot's performance. So let's dive in. So the first step in our journey was setting up the robot. So this involved selecting the right components, assembling them, and ensuring everything worked together seamlessly. My robot is equipped with four motors for four wheels. It's got two magnetic encoders for the front left and the back right. It's got a Raspberry Pi, which is the brain for our robot. It's got an Arduino. It's got batteries. It's got an IMU. It's got a distance sensor, and it's got a motor driver. Now, the assembly process was challenging, but it was a great learning experience for me. Each component had to be carefully placed and tested to ensure optimal performance. We also had a kill switch in the back that would just kill the robot in case of any unexpected behaviors. The next part of the journey involved completing several assignments that were designed to progressively enhance our understanding and capabilities. Each subsequent assignment was built on the previous one. Now, the first few assignments were focused on testing the camera and the distance sensor, and ensuring that they provide accurate data for the robot's environment and environment perception. Now, after that, the next set of assignments involved detecting green light. So we had a traffic signal and we were supposed to detect the green light from that. And once we have done with that, we will move on to the next step, which is essentially determining the direction in which the green arrow was pointing. This was crucial for developing the robot's navigational capabilities. We then moved on to testing the IMU and the encoder, which are essential for the robot's movement and orientation accuracy. Point being, IMU would help with the the direction in which the robot is moving. It would help in deducing what's the current heading of the robot and how to calculate errors appropriately. And the encoders would work on trying to move the robot in a straight line, that's number one, as well as updating the position as it travels. Finally, we worked on teleoperating the robot and using the gripper to grab an object. This step was quite vital for preparing the robot to interact with and manipulating the objects within the environment. So let's talk about the grand challenge for a little bit. So what is the grand challenge? So the grand challenge is the culmination of everything we have learned throughout the semester. The objective was for the robot to autonomously pick up the red block, green block, and the blue block. It's broken because I broke it accidentally. But it picks up these three blocks three times in the order of red, green, and blue. And it involves the robot exploring a cluttered area of different color blocks, and it finds the blocks, heads towards the blocks, grabs it, and then brings it back to a construction zone. So the home zone, and there's a construction zone. The robot starts from the home zone, picks up the blocks, goes to the construction zone. And that is the grand challenge. You have to pick all 9 blocks to get the perfect score. So let's explain quite briefly, how does the robot do what it does? So the robot starts by starting up its motors and its sensors. it aligns itself using the IMU, right? And it localizes itself using the walls that are around it. So it finds its initial X and Y positions using the ultrasonic sensor, distance sensor, and logs it. Once it logs it, it uses that as the base for counting the distance that the robot travels to. Now, once the localization is done, it uses the IMU to point towards the first color, which is red, in the slot, and it finds the red color, aligns the robot using the IMU values, and then moves forward towards the block. And as it moves forward, it counts the encoder ticks, and those encoder ticks are converted into distances. And that distance is added to the initial XY that we took while we localized it. Once it reaches the block, it grabs the block, and then it calculates the target position. So I had hard coded the target position and XY position within the construction zone. So it does the math between the current orientation angle, the current XY, with the target XY, and then rotates to face that XY coordinate. After that, it sends the bot all the way to the XY coordinate while also updating the encoder ticks, hence the XY positions. The moment it reaches the target position, the gripper opens and releases the block, and it relocalizes over there again. Because I did that because I assumed that the encoder counts will increase in error as it goes, it accumulates error. Same applies for the IMU. So I thought maybe relocalizing at the construction zone would be a good option, and which is what I did. And it worked for the most part. Once the relocalization is done, then it searches for the next set of blocks, which is the next block in line would be green, and it would hunt for the green block. Same process as follows. It goes, picks up the green block, comes back, relocalizes, then heads to the blue block, goes, picks up the blue block, comes back, relocalizes, and the cycle continues 2 more times. Once all 9 blocks are picked, the run ends, and we call time, and the entire run has to be done within 10 minutes, and each student gets 2 turns, and the best of 2 turns is your score, essentially. So yeah, that's how the Grand Challenge works, and that is how I had coded my robot. So finally, it was time to put everything to the test. So here's how the robot performed during the Grand Challenge. As you can see, the robot successfully did pick up the red, green, and blue blocks in the correct order. There were a few hiccups along the way, and it did cost me a little bit. And if you notice, instead of picking the 9 blocks, I was only able to pick 5 blocks. Now, why was that? I think that was due to a silly mistake from my end, because I could have modified my code a little bit more. My initial code for detecting the blocks and aligning my robot to it was based on simply drawing a straight line through the block. And what that means is, if the block falls down, it would still draw a straight line through the block. What I had to do was I had to take the aspect ratio of the blocks and basically put a check for the aspect ratio. And put a limit or put a threshold for the aspect ratio of the blocks. If it is below a certain threshold, don't consider it. Because if you see in the video, it got confused between the 2 green blocks, one that was toppled over and one that was upright. To the robot, both of them it was available to pick, but that was not the case. So yeah, if I had modified just a little bit of that code, then I think I would have been on track to pick minimum 7 or 8 blocks, with good luck on my side, maybe 9. So yes, that was the result of my Grand Challenge. Although I'm quite happy with my performance, I believe I could improve it a little bit more. So yeah.